Hello and welcome back everybody. Today we're flying the Boeing 787 here in this beautiful American Airlines livery. And I'm going to show you how I would set up this cockpit in FMC. I'm not rated on the 787, I currently fly the 757 and hold a type rating both on the 75 and 767. But the cockpit here and the FMC as well share some pretty common things, so I should be able to figure it out. So enjoy this video. So welcome to the flight deck of this beautiful cockpit, and today I'm going to show you how I would set up this cockpit and prepare for our flight to Casablanca. So follow along. Alright, so we see that the ground power is available and we would connect it. This is pretty special on the 787. It uses three sources for external power. On the 75, 76 it's only one switch. But this aircraft is like heavily reluctant on electronic. Alright, turn the battery on. And then I would start from up here and work myself down. IRS is on, both left and right. We can leave the APU off for now. I would just check that all the switches are placed accordingly. So here we see the off lights. Since the engines are not running, this looks all normal. And we come up here, put this to on, arm the emergency exit lights, leave the service interphone off. Put the primary window heat on. The hydraulics we're gonna leave off for now. Yeah, we can turn that to auto. Check that the landing lights are off. Yeah, the fuel pumps, they remain off for now. We can put the anti-ice to auto, and then we put the nav light on. All the other lights basically remain off. Some companies like to turn on the logo lights, but I'm just gonna leave them off. It's daylight, so they see our tail anyway. Alright. Here packs, they can go to auto. And this looks pretty much set as well. Alright. So next part would be to set up our FMC, which is really nicely modeled here, I think. I mean, there's some functions missing, but this is really similar to what I'm working with on the 757. This is just like way more modern and obviously integrated into a display. But from the basic functions, this is almost the same, and it's definitely Boeing logic. So I guess if you operate or have a type rating on one Boeing aircraft, the transition to another Boeing aircraft is not that hard, since the logic is pretty much the same. So usually on the ident page we check the model 787-10 and the Trent 1000, and this is really important here. You want to check that you have an active database which matches basically your current date. So today, I think when I'm recording this is like the 2nd of August. So July 10th until August 7th. So we're good for now. And we got some drag penalty, since the airframe probably is a little bit older. So yeah, this is usually indicated in, on our flight plan. Since if you have a bigger fleet with like 50 different aircraft, every aircraft has a different drag or performance factor. Alright, we come to the position in it. So we put Paris in here. And you don't have to put this in here, but it gives you a good reference. So basically you can compare the last position to the reference airport, and this looks pretty close. And then we checked with the GPS position, and those positions seem to be the same. Going over the route. And usually you would plug in the flight number, for example, if it would be American 12, I don't know, 45 today. Put this in here and then hit request. But yeah, I'm not logged into SimBrief right now. Maybe we can try this next time. So I'm just gonna put this all in by hand. So Paris. And then we're going to Casablanca, which is Golf, Mike, November. And I have not checked the weather yet. So I'm gonna leave the runway and departure and arrival blank for now. So we're gonna put in our waypoints. So the first one is, Agopa. And after Agopa, we go direct to Arkip. Then Armel. Artex. Then Bebix. So you see, it takes some time, and this is not the longest flight ever, but this is like a 2.5 hour flight, and it's already gonna take like 5 to 10 minutes to put in all the waypoints, which is pretty annoying if you don't have the A cars running. And then we're going to Vili. So basically here to the left you would put in airways, and here you put in waypoints. So OSMOB 5 letters indicates to us that's a waypoint. 3 letters usually is a VOR or an NDB. Then we go to Arvid. And Papa November. Alright, and so basically now you have to choose. So November 02, so 2 degrees north, it's 100% not going to be this one. And 18 degrees north, that is also way too low for our flight. So common sense would predict that the first one was the correct VOR. You can obviously cross-check this on a chart with the actual Latin logs. But this should do for now. Then we go direct Nolsa. Then Aleppo. Vasm. And then we got an airway, so November 10. And you insert this on the left. Okay, yeah. Invalid entry. Let's check. So November 10, then Bravo Alpha November. This is probably a VOR. And after that we go direct GoTour. Then Campo. Yeah, so North 55, that is basically too high of a lat long, so North 39 would make sense. Then Manto, Marlin, direct Victor, Juliet, Foxtrot. And then November 10 again. And then Linto. After Linto, we go on the upper November. So upper November 10. And then Barris. Barris, then upper Bravo 11. And then Tucson. And then finally we can activate. And then obviously I would check the weather, and then we would fill in the departure and arrival. So since the ACARS is not working here, let's check the weather like this. So we take Charles de Gaulle, and we got QNH 1019er. That is like the first thing I was set. So we come up here, switch attack to Pascals, and then we go 1019. So this here is just a MEDAR, and usually what you need is an ATIS, because on the ATIS it gives you some special instructions like which runway you can expect for departure, and sometimes they even tell you what kind of departure you should expect. Like sometimes it's labeled as expect 6 Bravo departures, and then you already know you have to look for 6 Bravo and the first waypoint that you filed. Or it could be any other information like birds in vicinity, etc. So for now, wind is 20. So 20 out of 20 degrees with 9 knots. So it's probably gonna be runway 0. What's it here? 07. 08. Yeah. So it's probably gonna be runway 08. So yeah. So we go to departure, and in Paris, it's quite a big airport, and yeah, basically have an east and west configuration. So it would be a east configuration, and since we are parked to the south, I would check my area south chart for the east configuration. And basically for takeoff, usually you would take the long runway, and for landing, the short one. Or basically you could say that the inner runway, so 08 left here in Paris, is used for takeoffs, and runway 08 right, which is the outer runway, is usually used for landings. So now I would go in here, departure, and we talked about it, 08 left, and our flight plan said Agopa. So Agopa 6, that should be it, and then we can execute that. And for our arrival, it was scheduled, we had the Tucson 1 Alpha. Obviously, during a 3-hour flight, things change, and you look at the weather latest like 30 to 40 minutes before you arrive at the airport, and then it happens that you get a different arrival, a runway change, whatever. So 2 Zor, 1 Alpha, and then ILS Zulu. Usually it's the Zulu, not the Yankee. And then let's check. I'm gonna check the chart here. So Casablanca, and then what's that? 3-5 right, and 2 Zor, 1 Alpha. Basically ends at waypoint code tag. So code tag transition execute, and now we basically would check the legs page and skip through all the waypoints and make sure that this depicts our route, which we have in our EFB, and as we can see there are no discontinuities, so that is pretty nice. We checked the distance, so 1137 miles. On my OFP I have written 1126 miles, so that's close enough. But if my OFP would have said like 1500 miles, I definitely knew that something was totally off, and I really had to go through the route again and check what I have messed up. So next step would be to request some winds, which is also not working since I'm not logged into SimBrief, but I have a wind chart basically with en route winds, so we can check. So Armal is basically the first waypoint. I have some winds, and cruise altitude was scheduled for 390. So I'm gonna pop in 390, and then I'm gonna put 370, 35. So this gives me options. Sometimes the flight level is blocked, or we have headwinds or thunderstorms, whatever. So sometimes you have to fly at a lower altitude, and we're flying in an odd level since we're going eastbound. So flight level 380 is most likely not an option. There are some cases where you would fly an even level on an easterly route, which is indicated on your chart, but in most times you can plan on the odd numbers if you go eastbound. And then usually I would take flight level 200. This just gives us a reference in case of an engine failure. This could be an altitude where we basically dive down to, so it gives us like a middle altitude between 390 and 0, just for reference. So this is also really a lot of work if you have to put it in all by yourself. I'm gonna remove this for a second. So now I would check my chart. So we're at Armal, and the wind at 390 would be 294. 294 with 38 knots. And I can pop this one in here, and 370 is 294 with 41. And 350, 297 with 44. Yeah, great. So 200 is not really listed here. We only have it in the climb. So 300 with 33. And you can add a temperature. So for example, I can add, when I check my chart, I'm gonna use flight level 350 / temperature -51. So now basically this calculates the assumed temperature for those flight levels according to the standard lapse rate, which is -2 degrees per climbing 1,000 feet. And at 36,000 feet, usually the temperature doesn't decrease anymore. So it goes all the way down to -56 on a standard atmosphere, and then it basically stays there for a couple of 1,000 feet until it actually increases, and then I think later on it will decrease again. So yeah, and now you could basically do that for all of the other waypoints, which I'm not going to do today. It's gonna take way too long. All right. So fuel, we have 111,000 pounds on board. Gonna check here in a second how much fuel we actually need. But reserves, yeah, I'm gonna leave that blank for now. So we're cruising at 390. Cost index 0. Step size 0. Execute it for now. Take the fixed page, Paris. $25 miles as a reference. And usually via route 2 is where I would set up our engine failure procedure, which is most likely gonna be straight ahead and climbing above the MSA and staying within 25 miles, which is basically the circle of the MSA. And then you would be safe. So that is usually what I would set up on route 2, but it's not working on this version. They got an alternate function here, so I will put in our alternates, which are Golf, Mike, Tango, Tango, and Lima Echo Zulu Lima. And then we go to, or the last alternate I should say, is Golf, Mike, Mike Echo. Alright, we got that going. So I'm gonna pull up the performance numbers with SimBrief, and then I will talk to you guys again. Okay, so I'm back with the fuel figures, and flight plan indicated to us that we need block off fuel of 46,000 pounds, and choosing 49.2 today, just round it up a little bit. But for the reserves indicated at 11,936, we would round that one up to 12,000, 12.0, like that. And basically now we would in real life wait for the load figures, load sheet, and you're gonna leave the performance page blank for now. So now I would continue with the further setup of the cockpit. We can actually initialize the flight and put this on for our performance calculations later. This is pretty close to what we use in our airplane. We got this on an iPad, the performance program, to get the speeds and landing and takeoff distance. And yeah, it's pretty nice. So yeah, you can adjust your lights here and just make sure that everything is normal. Cancel this, and you could actually go through all the messages. So yeah, something like hydraulic pressure is obvious since we are We have all the hydraulic systems shut off at the moment. We don't need them right now. Engine shutdown. It is pretty self-explaining. TCAS off. Yeah, and here we go again. Hydraulic pressure, center 2, center 1 pump, and fuel pumps, basically. Fuel pressure left and right engines, yeah. This is all expected. So parking brake set. That is all good. So we cleared all the messages, and that is important since if anything pops up right now, I would know immediately what the problem is. Because if you have like a million ICAS messages here, it's hard to tell if a new message basically has appeared or not. So yeah, always try to cancel all the messages after you made sure that everything is basically according to plan. So yeah, this page actually looks pretty similar to what we have on the 7576. So hydraulic system left, center, and right. Quantity is almost full. And we got no pressure. Yeah, APU is not running. Oxygen pressure is 1850, which would be, at least for the 75, this would be freshly filled up and good to go. So I'm actually not sure what the liquid cooling is. So maybe if somebody knows and has experience on the 787, they can tell me. I would be really interested in. And also all those pages, we don't have them on the 7576. This is really nice. It gives you a really nice overview of what is going on, especially with the fuel. So basically this indication we have on our overhead panel, and it looks similar to this one. So yeah, you can see center tank is empty. We've got 24.6 left and right, equaling a total of 49.2. And we wanted 46. So we got 3.2 extra to burn due to delays here in Paris, which is a normal thing, at least during day operations. Can get quite busy, and sometimes you have to hold for like 20-25 minutes until you can take off, since there's like 8 guys or something like that in front of you. Doors, etc. Yeah. So really nice flight deck. All right. Go up here. Make sure it's in hectopascals for Europe and most of the world. Flight directors on the auto throttle. And then we can start to set up our panel here. So we expect the Agopa from 08 left. So there we go. Got the chart, and the initial heading is telling me 084. So we would set our initial heading. Takes forever. And expected initial climb clearance flight level 120. So I would go 11.9, since we don't have a clearance yet, and this is a reminder for myself that we have not received a clearance yet with a specific altitude instruction. Auto brakes RTO, also indicated here on the ICAS, and we make sure altimeters are set correct. And DFO would also switch to, oh okay, it's already set at 1019er. And usually we would check here on ground that both altimeters basically read the same thing within some tolerance. So tolerance on the ground should be maximum 75 feet, And when we are airborne and we know that we are entering RVSM airspace, basically above flight level 290, we have to do an RVSM check. And the RVSM check should be that both altimeters should be within the 200 feet. If not, you would have to call ADC and tell them unable for RVSM, and then you would have to fly like in flight level 270 for today or something like that, which would burn way more fuel, and our fuel today with 49.2 is most likely not going to bring us to our destination if we would have to fly like at 270. So that is something to keep in mind. All right, coming down here, make sure the speed brakes are basically down, step trim, everything's normal, engine cutoff, flaps up, and go to VHF, and select the transponder here. So this should be at above. Okay. So yeah, usually you would toggle this to above during the climb out. And I think that if you have it on above, basically the TCAS shows you all the airplanes which are 9,900 feet or something like that above your airplane and 2,700 feet below. And basically if you flip it to below when you are in cruise, the main focus of the TCAS display is to show you all the airplanes which are like 9,900 feet below you and only 2,700 feet above. And normal, I think, is like 2,700 up and down, something like that. So yeah, squawk code is also received by clearance usually. So setting up the frequencies. So we're at terminal 2, Echo 18, and T8 should be 12713. So usually you would check the ATIS on this on the second one. It's not working. So usually what you would do is for number 1 you would put in the delivery frequency. That is where you would get your clearance if you don't use data link clearance. So we can put that to active. And then the next frequency anticipated will be either a apron frequency. So we got here apron, Alpha, Charlie, and Echo frequencies 12193. That is something we can set up. No, I deleted the other frequency. Yeah, but anyway, that's kind of how you would set it up. All right, next part here, I will show you how you would set up the performance, and we're gonna take the advantage of our flight sim that the airplane basically already knows the zero fuel weight and everything. But in real life, you would get a load sheet, and the load sheet would tell you what the zero fuel weight is. And basically the whole load sheet would read out how much fuel you got and how much taxi fuel. Everything is listed under the payload and then the calculated takeoff weight. So if we take our zero fuel weight, 388.6 plus our fuel equals a gross weight of 437.8. So that is in accordance with my flight plan. And the flight plan basically tells me to 434.6, but we added some extra fuel, so it looks absolutely fine since we put 3.2 on top of it. Then we come here to our performance calculator, and I guess we can copy FMC data. Yeah, and I already put in the information from our meter. So wind is 020 with 9 knots, outside temperature 19 degrees, and yeah, this should actually read 1019. All right, so we usually take optimum for everything. We don't need anti-ice. This is not working. And we check the numbers again. 437.8, 0 fuel weight, 388.6. And if everybody agrees, we can calculate it. So it tells us flaps 5 departure, acceleration height. This is for our engine failure. We're gonna set this later. Speeds 150, 154, 161. Selected temperature is 54 degrees. So our D-rated takeoff 2 rating should be 54.6 if I see that correctly. And then we can send the output directly to our FMC. Very nice and easy. And we got a message. Takeoff data uplink. Can also select climb 2 here to save on engine wear. And we accept speeds. So now we got speeds 150, 154, 161, 54 degrees, flaps 5. We would obviously cross check this. And 161. (161) is correct. After that we can arm LNAV and VNAV and the CG, which would be 24% and a trim of 50. So trim as of right now is set at 8.5. We cannot set this right now since the hydraulics are not working. So this would be something we would do after we pressurized all the hydraulics. So now we got the speeds and we have to set our acceleration height of 1845. We rounded up 1900. So go here to Barrow. I put it up to 1900. So this is basically the height where, in case of an engine failure, would be the earliest point where we would accelerate and could clean up or start with our aircraft cleanup, which means putting the flaps back to up and establish a clean flaps up, no drag configuration. Alright, so we got our MCP set, and that would be a good time to get the clearance. So let's just assume we were cleared via the Agopa 6 hotel. So it'll be flight level 120. Now we check with the route. So Agopa 6 hotel departure. And then usually you get a squawk, I don't know, some random number. And you would set that. And we have a departure frequency 133.38. Yeah, would usually pre-select this on the second comm panel. On standby. Yeah, haven't really figured out how that one works. Yeah, okay. I absolutely have no idea how to work this. Yeah, okay, now we go. So we keep the 121.5, which is the emergency frequency. We keep it active on 2, and then we put the departure frequency on here as a reminder what our next departure frequency is. And here we keep delivery or ramp frequency, and then basically ramp, ground, and then later we would switch here ground active, and sometimes you get a second ground frequency depending on the airport. If not, you can already pre-select tower frequency, and then when you are on tower, basically you put in your airborne frequency and you put it here on standby. And you would monitor the right VHF, so you could listen to basically guard. The frequency is called guard, so you would hear if somebody is in distress or whatever is going on. So that would be the setup, and then it would be time to perform a briefing.